Let's start by importing a PDF and working with that. The document that I've chosen is a memorandum from the CIA to President Truman on Soviet actions in Berlin from the CIA, and it was written in 1948. Rather than use the original, I've archived a copy at the Wayback Machine. Now, PDFs can have multiple layers. There's the layer that you see, the page image, and then there may or may not be a text layer that's hidden behind that can be searchable. One way to find out is to open your PDF in Acrobat or another viewer and see if you can search for keywords that you see on the screen. If the search doesn't work, there either is not a text layer or the text layer is so corrupted that it's missing out on those particular keywords. So we're going to use the import command to find out what elements we can get from this file. And it says one of the elements is plain text. So if we try to import plain text, and then we use the View Data Viewer, we don't see anything in there. So there is no text layer that we can access in this particular file. We can request other kinds of information, like the page count, for example. It tells us that it has 3 pages. So what we're going to do next is we're going to import the page images, and this is going to return a list of pictures. And we can get a sense of what the file contains by using a command called conform images on that list. Now what conform images does is it resizes them so that they're all approximately the same size. And I'm asking it to show us small pages. And here are the page images. There's the Wilson Center header, that's where this document came from, and then there's the 2 actual scanned pages, and we can see that they're going to have to be rotated before we do anything with them because they're lying on their sides. Now in order to perform optical character recognition, or OCR, we use a command called text recognize. And first, before I do text recognize on this, I'm going to resize the image. I'm going to multiply them by 2, so they're going to be twice as large, and then I'm going to rotate them minus 90 degrees, which will turn them from their sides to upright. And this is just for page 3 to show us what this looks like when we've done it. Now we can see that this document is physically quite messy. The quality of the text is not very good. It is human readable with a little bit of kind of squinting perhaps, but it's not going to be a particularly good subject for optical character recognition. We use text recognize and input the output to view data. Now when we look through this text file, we can see that some of the stuff is purely incomprehensible. Yeah, stuff at the very beginning is pretty incomprehensible. Some things like Central Intelligence Agency, Washington, D.C., are coming through. So if we did a keyword search on this text, we might get some of those important keywords. President. But when we look into the actual text, we see that it's pretty rough. Now one mistake that a lot of researchers make when they're working with digital sources, particularly things like scanned newspaper archives, historical newspaper archives and things like that, is they assume that if a keyword search doesn't reveal a particular document, that document does not contain that keyword. And as you can see, if someone were searching, say, for a keyword like Germany or Western, they're not going to get either of those in this particular passage of the text because the optical character recognition has gotten them both wrong. So you can never assume that a keyword search is actually going to turn up what you're looking for, even if it is in the document, if optical character recognition has been involved. Even with human editing, there are occasionally mistakes, but it's much, much cleaner than this. Now, not all OCR is going to be this rough. Here's another historical document that we can use. This is a memo on lunar exploration that was sent to Vice President Lyndon B. Johnson in 1961. We're going to load a copy from the Internet Archive. And this is coming to us as a JPEG, not as a PDF, and this is what the JPEG looks like, and that's pretty clean. If we do text recognize on it and then put the outputs in the view data command, in the view data viewer, we can see that this is actually a very nice clean OCR on this picture of a text. In fact, text recognize can do more than return just text. It can give us a bunch of other things a bunch of other information that allow us to tune it, and I'll show how that works using a photograph of a sign that was posted on Flickr. So here's our image that we're going to be working with. It is a picture of a sign. You can see that it's somewhat skewed, and that can have an effect on OCR. If we run text recognize on this sign, we can say, give it to us in blocks of text, and we want to output four things. We want to output the text, the confidence, the bounding box, that's the rectangle within the picture where that text appears, and the image that's extracted at that point. And I'm going to lay this out in table form. It's not going to fit on the screen exactly, but we can see, I'll scroll a little bit so you can see what it looks like. So the first column is our text, and as we can see, some of the text is recognized quite nicely, the historic village of Vicksburg, but some of it is not recognized very well at all. Mathematica has 92% confidence in this, which is good, less confidence in the other two. Now here are the rectangles that contain the text and the part that's been extracted from the original image. So this rectangle corresponds to the title. This rectangle corresponds to the paragraph of information. One of the things that we can do to improve character recognition is to focus in on the part of the document that has the text in it, especially in a situation like this if we have a lot of different things happening at different scales. So if we resize that image, trim it, and pass it off to text recognize, we can see that we get a much cleaner text recognition for that than we did for the previous example. Another thing that we can do in Mathematica is we can use text recognize to work on lines of text rather than blocks of text. So for example, here is another sign from Flickr. And if we use text recognize and we ask for lines and then the same information, it outputs the first line, please take your, that's correct, and the second line, not at all correct. But it gives us another way of approaching the problem of breaking down a picture of text into blocks that we might recognize or lines that we might try to recognize or do other tasks with. Another thing that can be quite useful, as we'll see as the lesson proceeds, is being able to identify where blocks of text appear on a page. So this is a page from a book that was published, or a little booklet that was published by the U.S. Office of Civil Defense in the 1950s called Home Protection Exercises, and I'm pulling page 29 from that. And I've actually stored a copy of that page so that we could just reach in and grab it. I put it on my GitHub account. Now if we run this next command here, I'll just show you how it looks and then I'll tell you what it's doing. We say text recognize, home protection exercise, line, and what we want to return is we want to return the rectangles that go around each line of text. That's what the bounding box is. And then I use highlight image to draw the boundaries around those. And as you can see, if you look at these purple boxes, that they're actually quite good at identifying where there are lines of text on this particular page. It makes some mistakes. It gets the top of this fellow's head. It thinks that might be text. And down here, it thinks that some of this stuff is actually text rather than a figure. But for the most part, it does quite a good job of identifying where the text is. And as we'll see in the next part of the lesson, that can be very useful for other tasks.